let's take a look at equivalency and rewriting different forms of an equation, getting two equal expressions. So let's say you're given an equation like this one, y equals 2 times x minus 3 squared plus 4. That is currently in called what we call standard form or graphing form. So that's graphing form of the equation. If you have an equation like this that is currently in graphing form and we're switching it to standard form, we have this original equation with the 2 times x minus 3 quantity squared plus 4, and then you can start working on the part with the x minus 3 squared. You need to do this part first, and then that gives you x squared minus 6x plus 9. Then there's going to be a distributive property here with this 2. And when you distribute that 2, you get 2x squared minus 12x plus 18 just for this first part, and then the plus 4 comes down. And then the final step is to combine like terms, and you end up getting 2x squared minus 12x plus 22. Well, if you think about this is now what you have, this is up here what you started with, wouldn't those two things then be equal? And so you have found an equivalent expression. So this expression equals this one. They are mathematically the same. They are mathematically equal. Now, in order to kind of get into the details here, you're looking at this first one as being in graphing form because we know that this is the vertex with the 3 and the 4, and this one's in standard form, more ready for like quadratic formula if we were going to work with it. Different equations that represent the same parabola, and what you should be doing is comparing these on your calculator. Put this first equation in as y1, put this second equation in as y2, and check the tables, check the graphs, and that's your proof. So if you want to know if you're doing your work correctly, take a moment just to type them in and see if the tables match and the graphs match, and you have the proper equations. Okay, which expressions are equivalent to 6 minus 2 times? And then we've got this x plus 3x in parentheses here. So if you want to think about it, now you can see that I've got this simplified down to 6x minus 8 just by doing the distributive property here and here. And then this one is negative 8x plus 6, which those two things are the same. They're just written differently. So I know I'm going to pick this one. And then this one obviously is 6 minus 8x as well. So I'm going to pick that one as well. So I have two solutions that I like for this. What could we do with this expression? How can we change it? How can we rewrite it so it is more of a familiar format for us? Well, what can you do with this expression over here? Because this is one of the answers, and this answer right here is kind of a jumbled up mess. So I want to do some math with this. I want to do some math with this because maybe there's more than one solution here. Okay, and then we can verify these algebraically and numerically. Algebraically being we can move the letters around. Numerically would be if we just plug in numbers. Like what if I think of a number and I just plug it in and it makes the equation true? If you wanted to check it numerically, I like using a number like 10. 10 is an easy math number, and if you use 10, it's a number that's plugged in pretty easily, and you can just go up here and say, okay, I'm going to put 10 into this equation for x, and I'm going to put 10 into this spot for x. Then what I would have is 6 minus, and then this would be 3 times 10, which is 30, plus 10 is 40, so this would be 10 plus 30, which is 40, minus 2 times 40. So then I've got negative 2 times 40 is negative 80 back here, and then 6 minus it makes negative 74. And then if I was to put in 10 into any of these, like if I put 10 in here, 8 times 10 is 80, that's 6 minus 80. Well, that's the same thing, so this one would work. If I put 10 in here, I get 16. That doesn't work. If I put 10 in here, I get negative 20 plus 1 is negative 19. And negative 19 times 4 is 76. And then I would have 2 minus 76. And so then that would give me the negative 74. So this one would work. And then if I put 10 in here, I'd have 6 minus 50. And 6 minus 50 is negative 44. So that one doesn't work as well. So that's a numeric proof. We had previously done the algebraic proof. Here's another example of working things around and simplifying or just plugging in numbers. For this one, it's already simplified, so I can't really tell what it's looking like. So for me, I would like to just plug in a number like a 10, as I suggested. So if I just plugged in 10 into this spot right here for x, I would have 2 minus 10 plus 12 divided by 4. Well, that's 2 take away 22 divided by 4. And 22 divided by 4 is 5.5. So then it's 2 minus 5.5. So that's negative 3.5. So I just got to figure out what other ones equal negative 3.5 while plugging in a number like 10 into there. So if I put 10 into here, I'd have negative 5 over 4. That's not the same. If I put 10 into here, I'd have negative 1 minus, and then 10 divided by 4 is 2.5, so that makes negative 3.5. So we have a winner here. There's a winner. And then if I put 10 in here, that would be negative 11 divided by 4, and negative 11 divided by 4, that doesn't work either. Then if I go down to here, I would put negative 10 into here, so now I've got negative 14 divided by 4. That's better because that's negative 7 halves, and negative 7 halves is in fact negative 3.5. So I'm going to take that one as well. Think about what you can do to each expression. You can try to simplify things or divide things out to try to make it work, or plugging in a number like a 10 is a good thing to try. Now that you know how to compare two expressions and see if they are equivalent, next we'll be determining when expressions are equivalent.